let us take the call. Let's go ahead and start with it. Otherwise, he'll ask question.
So, is it clear now for you? I'm just hoping that this time it is clear. Although, all right. So I was describing how would you say that I'm trying to apply a filter. Currently my line length is something of this sort, right? So we have got these line lengths. Now these are top 10. Said take 10. Okay. So now if you have to have line lengths, I want to say, what do I want to do? I want to filter only the line lengths having the even values. Okay, so even lengths. Can you hear me, all of you? So I'm trying to apply a filter. I'm saying filter, and then lambda is a notation saying that I'm creating an anonymous function, just like new function in JavaScript, and I say that this is my length. Okay, we call it L. L is the argument available to it. Now L percentage 2 equals 0. Okay, which means, or L L percentage 2 equals to 0, which means divisible by 2. So only in those cases when this condition returns true, the value will be put into output. So did I make a mistake? Yeah, typing mistake. All right. Now, if I say even lengths and I say take 10, then I will see that only the numbers you can see now only those lengths are returned out of line lengths which are even in nature. Okay. So this way you can you could also run this filter on top of lines itself and say where length of line is divisible by 2. Okay, now if you say even lengths dot take 10, now you should see the top 10 elements of it. So these are the lines which have even lengths, top 10. Okay, if you want to save it into a file, you can save as text file, and so on. Okay, so I'm trying to demonstrate how could you use a command line parallelly describing what is a transformation. So filter is good for everybody. What type of machines are suitable for Spark? Spark can be run on any machine. Right now it's running on a machine which has 4 GB RAM, which means it can run on anything. Okay, and it automatically adjusts its memory depending upon your requirement. All right. Now, so filter is clear to everybody. Map is clear to everybody. In map, it's one-to-one relationship. From a value, we translate it to another value. That's all. While flat map is something which is very analogous to our map reduces map. Our Hadoop's map reduces map is analogous to this flat map. If you want to convert a variable here, if you want to take the line and split that line split the line by words and generate multiple key values for a value for a particular line. If you want to generate multiple key value, you can use flat map, right? And other transformation is group by. So you can very closely look at these and feel exactly like the way you felt while working on pig. So in pig you have for each, here you have map. In pig you have filter, here you have filter. In pig flat map is something which is done by for each itself, so there is no other function. Now now here group by key is group by of pig. So whenever you say group by key, before that you have to run flat map so that you can generate key value pairs. Okay. Okay, so group by key is basically first you generate key value pairs using flat map and then you run group by key. And there are many more examples you can see of various transformations available from Spark. So everybody is okay with this? So transformation is something which basically translate one data set to another by applying these functions. Okay. And you will notice in all of these, unlike our traditional programming where we used to execute our function right away, here we are executing these map, filter, map, and asking these methods to execute our function. Why is it so? Because the execution of your function is going to take place on multiple computers in the backend, and therefore they take your function and they run that function on multiple node. That is the role of the transformations. All right. Now the next topic which is there is actions. Yes, taking computation to dataset, exactly. All right. Now when we did transformation, data stayed on RDD. It did not come to Spark driver application. That function, the demo I gave, take 10, or take one, all of those functions were basically actions. Actions are something which cause the movement, which cause the execution. Okay, transformation is just a definition saying कि whenever an action get executed, then those transformation will run, right? Okay, can you show us an example of group by? Yep, I can show you one example of group by. And let's say this data set, and okay, so we have line lengths, right? Let me line lengths. Okay, we have line lengths. Now let's convert it into line lengths key value equals flat map. What I'm trying to do is on the top of line lengths, I'm saying flat map, and I'm saying lambda my length, which is there. Okay, and for each of the length which is there in the line length, what do I need to do? I need to generate I need to generate length and 1. Okay, now you can see lkv dot take 5 and let's see what does it do. So int object is not iterable. Line length, flat map, lambda. Okay, okay. lkv dot take 5. So we got this. All right, let me just have a look at what was I doing. Okay, okay. First, let me just generate the map. Flat map is for multiple value. Here we don't want flat map. We want basically a map, and all we want here is okay. All right. So we have the first word. This is the first word, and the second one, and that's it. Yeah, this is correct. Okay. Okay. So basically I was not forming the tuple correctly. Now it is formed. The tuple is correct. So all I need to do is now on top of this I say grouped equals lkv dot group by key, and there what do I need to do is group by key. That's all. So we have already provided a key. Okay. So grouped take 5. So it has got these results. It is grouped. These are grouped. And then once you have these groups, right, all of these 0, 2, 4, and then you have got these arrays, right? Then you can reduce by key. Okay. You can do a reduce by key. Okay. What happened to my UI? Okay. Now you can run a reduce on top of this. So we got grouped, right? Grouped has, so my values equals, okay, just a second. So we have got what? Grouped, right? Grouped dot dot, we say reduce, and then we define our function lambda, and whatever values we have got, say there'll be always two values, a comma b. Okay, there'll be two values, a comma b, and then we say a plus b. Okay, all I'm trying to do is count. Let me just see. Lambda takes exactly one argument. All right, so it has basically done nothing. So for all values, all it has done is, okay, so it's a iterable, and so ideally the, okay, reduce by key, is there a function? Okay, 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 I need to actually look at reduce this aggregate, basically group by, because group by is working fine. All it is doing is basically returning an iterable here. Now what do we need to do with the iterable? How do we need to do a for each on this, and what do we need to do, that we need to see. Yeah, actually we can do for each on this. No, don't worry if you're confusing, don't worry. So this is group by, and we say for each, and for each, then again key value, and then we sum up the value. Okay, what does it say? All right, all right. Okay, so basically grouped is okay. It's just that I am yet to figure out what do I need to do with the iterable. You can see the iterable over here. So it has grouped our values by the key. When we say group by the key, so it has grouped. Now this needs to be converted into the real value. Okay, this needs to be converted into a real value, and how would I do that? Yeah, basically I need to do a summation on top of this iterable, and that's all. Okay, all right. Okay, so yeah, so group by I can show you a little bit later. Okay, because I was expecting the summation would apply on iterable, right? Now let's just move a bit more so that before we confuse everybody. Now, so we talked about transformation. We are able to transform data into one form to another. Then we talked about map, filter, filter map, and group by key. So we are successfully able to group by our data. Okay. Now, the other thing which we talked about is actions. Actions basically actions basically bring, okay, actions basically make the execution. Actually, this diagram is better. So actions basically first make the transformations happen, finish, and then bring all the data provided by the transformations to the driver application back. Okay. The simple example was take 5, take 3, count. All of those basically did the job and brought the data back. The result of any action is not a RDD. The result of every action is basically a result of every action is essentially a value which you can basically you got a value back at the driver application, and you can do whatever you wish to do. All right, you can do whatever you wish to do on that value. So right now, so examples of actions is reduce. Okay, reduce is like your combiner function. If you remember combiner function, which has to be associative and cumulative, and basically it will reduce function will be applied on two values at a time only. Okay, unlike our traditional reduce function which will be applied on all the values at a single go, it will be applied at two values at one time. Okay, so if you have an array and you want to do say you have we have line lengths, right? line lengths line lengths take 5, right? Now we want to convert it into a number. We want to do a summation on top of this number. Okay, so what we will do is we'll say reduce, and then we'll define our lambda function. I mean our anonymous function. We call that say a and b. These are the two arguments we are passing to it, and we put optionally, yeah. And the thing which we want to return is this. Now what will it do is it will give us the summation of all line lengths. You can see this number. Okay, and we can also assign it to total. So if you see total here, it says that it's a number. In case if you say line lengths, for example, it's a RDD. Line lengths is an RDD on which we are applying a applying a basically a reduce function. Okay, reduce function is an action which convert an RDD into the normal value, and it basically makes all the action happen, all the transformation which are pending before this action, before the execution of say line length computation. Line length computation is not done right now. Line length computation will be done only when we access it. Okay, only when we run an action on it. All right, so here we go. We got a reduce function which does all of this. All right, so this reduce function, say we want to do a minimum of, okay, so we want to say a greater than b question mark a otherwise b, and I'm not sure. Okay, in this case a plus b means that we add length of two lines only or more. Very good point, I was about to explain that part. Here when we say reduce, we are saying reduce the whole array into a single number by applying our function, whatever function we are defining here, again and again on the whole array. Okay, so it will take two values out of that array at once and sum them up, then take another two values, then sum them up, and it will keep on doing again and again. And then after it finishes processing the whole array, it will start processing the results of the previous iteration. And so by taking two elements at a time again and again, it will do the summation of the array. Okay, so also note that reduce function or any action also happen on the nodes. Okay, different nodes. It's just that actions bring the data back to the singular node which is launching the applications. Okay, now here you can see now total has been computed like this. Yes, so those are the arguments provided to you. The other way you can handle, let's say we define something called a min function. Okay, min function takes two argument a comma b, and it, okay, if a greater than b, then it returns a, else it returns b. Okay, this is our main function, and if you see the output of main function quickly, it basically returns, sorry, it is max function. It has become wrong. Okay, so basically I have coded it wrong, so it returns the max actually. Okay, so I'll just do max equals min. So can I, yeah, so now this max, if you want to compute the biggest line on, so I've just written a function called max, which basically takes two values, provides you the maximum of 2. And now let's try to find out the biggest line in our input text. Okay, here instead of now writing lambda, I'm passing my function max. Okay, now what did it do? It stored the value in total, and the biggest line in this text is 2541 character long. Okay, so just like it did apply summation on two value at a time, in this way, similar way, it applied my min function again and again and again and again on this list of values. Okay. Okay, so those of you who are hesitating in experimenting with this, you can actually do this way also. So let's create an array of some values. Okay, this is my normal array of values, and I say sc dot, and we call it my ardd equals sc dot parallelize, and I say a I don't know, I'm pretty bad at spellings. So what I can do is dirsc, and it will tell me what are the various functions available on this particular object. Don't worry in case you, so I'm pretty MNOP, where is my P? Here. Okay, so in case you get stuck, you can say on any Python object, you can say dir, and it will show you all the functions look available in that object. Okay, so that's a good lesson for you. And parallelize, and I say a, and now a rdd equals this. Now I've got rdd created for myself out of this array a. All right, and then I can apply this reduce function which we just created, reduce and max, and that's all. And there I go, I got 990 immediately, right? So is it clear to everybody? all we did is first converted our array to a, by parallelizing, created a RDD out of an array quickly, and then I ran the reduce function. Okay, so this kind of small functionalities available make your life easier, and will be, I mean, it will be easier to experiment also. All right, and that is the reason I have chosen Python for this demo, although I have most of my life coded in Java. All right, so there we go. So you can clearly see, right? Right. So it's finding max recursively by applying two values at a time. So if I create another array now, and if you see the average, right? If you see the average, let me try to do a function called average. Okay. And average is what? Average a comma b, and then I return a plus b divided by 2. Okay, and now if I try to do that kind of thing on my, okay, now if you see, it has given me this value. Is it correct? So here this is correct, but let's if I try to twist it a bit, 2 comma 1 comma 384 comma 990, and then let me create a RDD on top of it. Okay, and then again, oh, we are lucky actually. We are lucky actually. It is doing good. It's basically sorting the values and then doing the average. Otherwise, it could have been wrong. Okay. Yeah, I think it's sorting the values. Internally while running this, I think, yeah. Oh, we are lucky actually. It's doing the good job. Otherwise, the function average will give a wrong results, because average is not cumulative and average is also not associative. All right. So count is of course pretty simple. On any of this, count basically triggers the result, and you get the value immediately. Okay, let me try what he's saying. So let me say my a equals this, and then I say a RDD equals sc dot parallelize, and then I say average equals a RDD dot reduce, and I say reduce, and I say FG. Let's see if, oh, I need to put commas. Good, good. All right, now we see, oh, it's still good. It's still good. So I think it's internally sorting the values or doing some magic, because I do not expect the values to be correct. If you see this summation of a, what do we mean when we say parallelize? So we have got this local variable, an array, or we have got a file in HDFS, or we have got a local file lying there. We want to create we want to create a resilience RDD on top of any of these data set. And what does it mean by it basically distributes the data on multiple nodes when you do that? Okay. If there are multiple nodes, it will distribute this data to the multiple nodes. Okay, so we have got count, and then if you want to collect all the values, so we just now created our this, and we want to get all the values instead of take. Okay, we want to get all the values instead of saying take 2, take 3. Then in those cases you use collect or take, anyway we have been doing. So similar to our pig, there are other, these are collect, take, these are good for limit. They are similar to limit in SQL. Count is also similar to that. And count basically does a distributed job, okay, in that sense that it asks all the nodes to give the all the RDD parts of RDD which are located, partitions of RDD. It asks for them for counts of the variables, and then it returns. Okay. Now, now if you want to save this data, you can save as text file. Okay. You can see more functions on any of the RDD you create. Okay. You will see there is a function sort by key, stats, subtract by key, and all of those functions are there. And I'm just seeing that. Oh, I had to use aggregate by key instead of reduce. Okay, this is what I had to do. That group by thing you remember, which we were talking about. Then aggregate by key will do the job. All right. So take sample is similar to our sample command of pig, where we can take a sample of the whole data set. All right. So in take sample, we provide what is the I mean, we run the take sample on our data set and say that we want this fraction of total data, and this is our random seed. Okay. If you want to save it in Hadoop, you can save it. So if any of the file you want to save it, you can use save as Hadoop file, and so on. All right. Now that's pretty much about actions. Now let's move on. We go ahead. So this is clear to everybody, right? This function execution we're talking about. Why why average or the other functions are not a good candidate. Okay. So those who have attended the combiner section where we talked about how does a combiner work, it's the same thing here. Okay. So on a single node, the way it happens is recursively, as somebody was asking, as Sanjay was asking. So this is how it happens. Had it been a single node, some could have been straightforward. How much? Anybody? Some could have been the summation of all of this, which is 62. Okay. And That is on single node if you're trying to do a summation or counting the line lengths on each of these nodes. Now, what we want to do is we want to parallelize it, and our sum function will be executed in this following manner. So we have got node 1, node 2, node 3. Some portion of our lines went to node 1, some portion of line went to node 2, and some portion went to node 3. Okay. After that, we computed the line lengths. On each of these nodes, we have got different line length, right? Bhagwat Kumar has got different line length, and this has got different line lengths. Anto has got 4, this has got 20, and so on. Now, when we say sum, so first node, the summation computation will be like this. So summation of two values happen first, then whatever output comes along, then that is further added, right? So on node 1, the summation is 24. On node 2, summation is 14. On node 3, summation is 24. Again, these three values will be summed up like this. Okay, and finally we'll get 62. So is it clear to everybody? Because our sum function or aggregate function only takes two values at a time and then returns the result. And I need to understand, as a takeaway from today's discussion, why average is giving correct results. The only theory I can have is that the data is sorted and only then it can get these kind of results. Right? Or maybe it's using some other function. Is it my function? I think it sorts the data and then does the job. I need to do a little bit of research before I talk about it. Alright. And yeah. Now, the other portion, so far, most of the work looked like a derivation of map and reduce. There are few more additional advantages which Spark provides you, such as broadcast variable. This is pretty nice thing. It serves like a sort of a cache for you. Okay. So you create a broadcast variable which can be accessed by all the applications running across your cluster. So you have got a Spark application which is running a map. Okay. What does map do? Map basically runs your function on multiple nodes. Now, when this function is getting executed on multiple nodes, what you want is this function should be able to access few variables which is uniform across all the cluster. Okay, in those cases you use the broadcast variable. It serves like a common cache. Okay, in our word count example, if we had to remove the prepositions out of all the words, or so we might have to share a common memory across all the nodes, right? And that is where the broadcast variables comes into play. Also, the good part about broadcast variables is that we can broadcast as and when we want. Okay, if you want to broadcast new set of values, we can broadcast new set of values immediately, right? So it sounds like cache, but there are really decent amount of work that has been put into broadcast variable. So when you are broadcasting a variable, what happens is that immediately all the nodes are notified that the data has been stale. The data in the broadcast variable is stale, and all the nodes will wait till the data refreshes, which means the reflection of the changes in broadcast variable is fairly immediate and there will be no inconsistencies per se. Okay, so the moment you change a broadcast variable, all the Spark applications which are running across the RDD and depending on this variable will be notified that hey, if you are using this variable, just wait, the data is coming in. Okay, so all of those nodes will wait, and that wait is being implemented by a function called value. Basically, a broadcast variable is a wrapper over normal variable, and whenever you want to access the value, you use the function called value on top of the broadcast variable, right? So it's a very cool thing to have, that we have a shared memory. If you remember, most of the people, when they are writing MapReduces, they come up with the idea that can we have a shared memory. I recently, some of the students, they wrote a mail that in their project they need to share the memory across. It's a common phenomena. Okay, so although in MapReduce you can access the database or any memcache or any other database such as Redis, but sharing the variable across the cluster is so common that they have provided, Spark has provided that basic feature. Sounds good? Now, if your Spark application or your maps which are running across RDD, they want to spit out the values continuously to a central agency, then accumulator is one cool thing. Okay, accumulator basically gives, it doesn't read anything from, basically accumulator provides the one way writing. Okay, so Spark application basically gives the accumulator the counts. So all of these nodes which are running your Spark application, they will be telling accumulator plus one plus one plus one plus two plus three plus four and so on, and that's how it goes. and and accumulators are only added kind of operation, so order of the values does not matter. So whether plus 10 came first or plus 20 came first, the answer will be same. Okay, so that is what we call accumulators. Will have a good example now. So if you have to do the word count example in Spark, this is what you will do. Okay, this is a little different example from what everybody does because it cleans up a lot of things. Okay, so first we import regular expressions, imported, then we load our big.txt, done. Okay, not really done because this guy has put, okay, and loaded. So this, we loaded this big.txt into lines. Then next thing we did was we run our flat map. Flat map, what did it do? It splitted our file on based on space. Okay, and let me just also see if we can have Sandeep and Giri, and then I say split and I say tab. Good. And if I say, mhm, it doesn't allow you. All right. So yeah. So next thing we do is that given lines, we convert that into words. So basically, if you see fm dot take 2, take 5. Okay. So it will give you a result like this. It says that Unicode string the project and Gutenberg. This is what we have gotten out of splitting. So the whole text has been converted into words by splitting. Now next thing we do is we run something called map, and as a result of map what we are going to do is first we are going to replace non-alphanumeric character with nothing. We are going to remove non-alphanumeric characters and we are going to lower the casing. Again, some problem do you see? Let me just check what. All right. So this is now M has been basically we have removed all the non-alphanumeric characters and also we have converted the word into lowercase, right? So here if you see m.take5, it should give you, yeah. So everything has been converted into lowercase. Good. Now next thing we do is we do the count. Okay. And the way count is done is we say here in this one, when we said map, we did three things in a single shot. One, removed non-alphanumeric, converted the key into lower cases, and from an array of words, we have converted into key value where value is number 1. Okay, these are too many things done in a single shot. Ideally, we could have removed this portion out of it and kept it separate. Okay, we could have taken this section out of it at least. Never mind. So now what we are going to do is we are going to reduce by key. So key is the word which we have provided here. This is the key. This is the key. You see U is basically representing that the word is in Unicode. Okay. All right. Now we have got counts. Reduce by key we have done. If you see counts dot, so counts is still a RDD, and when we say counts.count, it gives us the result. Though what we actually want is we want to save our file as a text file. Okay, as a text file. Let me call this as 8 November, right? Just like we had in pig, say store function, exactly in the similar fashion we have this. Okay, now this would be, and we can exit from here. Okay, or we can just go over here. Alright, so we go to asgiri and then word count and then output word count and then output November 30, and this is what is created just now. You can see, so it is now cleanly done. No, actually we are looking at the wrong method. Spark 8 November. We have to look at Spark 8 November and the under output folder Spark 8 November. Now you can see, right? So this is how it is saved. Sounds good to you? So we are able to do computation on top of it. So the next example in this case is it basically removes two things. One, it removes these broadcast variables. Okay, it first uses the broadcast variables in which the in which we what we want to do is we want to remove these common words called a and the this that and so on. This is what we want to remove. So we created a broadcast variable and we run one of the here. Okay, here we run one more filter called on which we run our filter function, this one, which checks whether whether our word exists in this broadcast variable or not. Okay, and that's all. That's all. Okay. So basically, this example shows you how you can utilize broadcast variable to remove certain keywords. So here we run one more thing after just after running the map, we run filter. We remove all the words from input which contain any of these keywords. Okay. All right. So, do you guys want to do it by yourself or you want me to run it? Although it will run as is, but you should actually try it out by yourself. So, it contains two things. One is accumulator, and you see the accumulator basically every time the filter function is getting executed, accumulator is just adding it. Okay. No matter this filter function executes on one node, 100 node, it will do the job really good. Okay. So that's pretty much from the accumulator side, right? So let's take a quick break of 10 minutes. Okay, break of 10 minutes and meet at 10:0 10:19. Okay. So after the break, we'll be talking about Spark streaming. Hi guys, I'm back. So, Naveen, are you back? Can you hear me? Good. So basically, all of these hands-on exercises are fairly new. Okay, and this is specifically, basically, we are able to now run Spark on our Cloud Labs. Earlier, we were not able to run Spark on our Cloud Labs. So, so it's happening for the first time. So we have these examples for the first time, and therefore you don't see it in the website. Now you will see in a couple of minutes. Okay. All right. Good. Good. Okay. Accumulators, right? That's what you mean, Naveen? So I mean, accumulators basically is one-way storage. Okay. And when your l- Spark application just need to inform a central agency, you just keep on giving it out. So examples of accumulator could be, say, counter, web counter, debugging information. This function has been called this many times, and so on. Okay, this is like append only kind of uh, systems. So accumulator is actually pretty simple concept. It's like a central counter which is being increased by all of these people. And all of these people, as in all of these nodes, are telling a central agency that increase the counter by this much, increase the counter by this much. So that's a kind of accumulator. Right? All right, now we have got these examples in place. This example you should try. Both of these examples you should actually try. This one, second one, definitely you should try and try to understand what's going on. Okay. So So in case you want to do a development, then these examples are good. Otherwise, the SQL which is provided on top of Spark will be sufficient for you. All right. Or if you want to do some complex work, then you will require this. Now, let's talk about Spark streaming. Now, since Spark was able to provide a memory which was really, really fast and was heavily scalable, it became very suitable for streaming kind of a work. What does it mean by streaming? When the so let me just take to the next slide. So whenever there is an input data that is coming really, really fast, you want to do a lot of computation, and you want to do some computation on the input data as and when it comes. You do not want to wait for a whole day for the data to settle down and then you start processing. Okay. So standard examples of a streaming is, first, streaming doesn't only have to do with the video streaming. Streaming is a general concept. Whenever you have to do a lot of live processing of the data and give the results. For example, you have built an analytics tool, web analytics specifically, just like Google Analytics. So users are coming in, that information is flowing to Google's database. So on our website, we have this Google Analytics enabled so that we know which all users are coming in. And probably every website has that. Now, all of this data flows to Google, and Google keeps on doing a lot of computation live, okay, such as users in last 1 hour, users in last 1 minute, users in last 10 minutes, and all of that. Okay. So that is done generally by Spark streaming. And the the thumb rule in any streaming is you convert the whole input into discrete windows of values. Okay, you convert discrete windows as in 1 seconds window. So every second you will do the computation. That's exactly Spark streaming did. What they did was they took the input stream that is coming in as continuous per milliseconds or maybe per microseconds that is coming in, and they put this data onto a resilience data set in a window of 1 second onto the resilience dataset. Now, the key for this data in resilience, it's sorted by the key, and the key was timestamp. All right. Now that's what Spark streaming did. Now, once your data got into Spark as a resilience dataset, now you can run all of those things which we just talked about. The actions and transformations, you can run all of those and do whatever processing you want to do. Okay, because the data is broken down into sort of batches, buckets, and the key for the bucket is timestamp. All right, that is how the whole thing happens. Right, now you can see that. So internally, RDD is represented like this. So for a so Spark streaming basically came with the class, or came with the abstract idea called D stream. D stream is discretized stream, which is basically converting an input stream into an RDD such that data from 0 to 1 is on one partition of RDD, data from time 1 to 2 second is on another one, and so on. That's what this class called dstream does for you. It breaks down the input stream into windows. In the windows, is it window of certain interval? Okay, and on top of it, dstream provided you really nice functions such as pairs dot reduce by key and the window. Okay, reduce by key and the window. So that's additional features dstream provided. So whenever you're doing computation, you are always talking about a window instead of only talking about your data. So in this one, this okay. So what we are doing here is first, in the first step is, it's a little deviation from standard Spark. What you do first is you first create. This is a Java example. All right. So here, first of all, we connect to our stream from which the data is coming in continuously. And once you have got hold of that stream, you are pushing this. This stream is going to push the data to your Spark. Okay. So this is how you initialize the process, in which you say that read the data from localhost 9999 port continuously, and and you basically read the data at the duration of 1 second. Okay, 1000 millisecond, that is 1 second duration. Once you are in place, right? Once you have created these lines will now act like a RDD for you. And on top of these lines, you can do all sorts of things like flat map and all those things it will do for you. All right. Once you have done a flat map or any other kind of functions, you basically have your result, and then you can push it to anywhere. Okay. Okay. So Okay, okay, no problem, Vishal. Yeah, you can take a break. I'll continue with the session. You can go through the video. All right. Now, on top of words, we can run a map function, and then you can do the pairing. Right. So whatever. So here I showed you that we did a flat map here. In the flat map, it's a standard example. We are trying to split the data by space and trying to count the word per second. The overall objective of this exercise is counting the words per second. Now next one is converting into a map, and then once we are done, we have reduced by key, and that's all. So after all of this exercise, you will have your data being printed every 1 second for you. Okay, this will give you the results which is being printed every 1 second. The word count that is coming in on a particular port every 1 second. Okay, so that's what is the role of Spark streaming. Now, basically, the way it has done is the for first in this example, what we have done is lines came from D stream. For first second, it converted into words and then printed it, and that's what will be the output of it. So basically, we did map reduce on top of an streaming a live example, a live streaming example, and that's what is the role of a streaming. The other tools which are used in industry for stream processing is Apache Storm. It is fairly distributed system. It's a distributed real-time computation system, and and has been in production for quite some time. It has been in production uh, for quite some time. Okay, so whenever you want to do a lot of live real-time data processing of big data, either you use Spark or you use Storm. Okay, I'm not going into Storm right now because that will be another big example. So in case of Apache Storm, it basically uses real-time analytics. Can be, I mean, the basic uses of Storm is like any other real-time analytics, any other stream processing. The role of Apache Storm is analytics, live machine learning, continuous computation, and all of this. All right. And the good part, when you compare these two, right? When you compare Storm and Spark, whenever you are in this situation where you have to take a call, which service to use for stream processing. So these are the pros and cons. So Spark has got a bigger latency as well as unproven system. Unproven as in it's not in production for quite some time. While Storm has been proven at Yahoo for quite some time and has got a sub-second latency. But if you have Spark in place and already using it, then there is no point in investing much in Storm. Most of the work could be done easily. Okay. All right. So all right. So that was about comparison between Storm and Spark. The important part is that Storm has been in production and is being used at Twitter and Yahoo for quite some time. The downside of Storm is that it doesn't work on Yarn but works on Meso's distributed computing environment. And the the Hortonworks does not ship Spark by default. You'll have to install that, but Storm is available by Hot and Work. So this is how it is. All right. Now, any questions here till now? Naveen? So all of you are with me or okay? Yes, go ahead, Sanjay. So feel free to ask questions. Okay. Otherwise, I start rushing into the concepts really fast. So Spark can be used in place of Hadoop. The answer is yes. The answer is yes. Mm, but I mean, it's quite early to say so. There is no practical replacement for HDFS right now. So whenever you have big data, you will have to anyway have HDFS in place. Okay. And when you have HDFS in place, you by default have MapReduce in place. So these things will go together hand in hand. And it doesn't take much of your resources. It just takes few MB more on 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 your data nodes as well as this. MB in the disk, not in the memory. Okay. So it will not be completely ruled out not to use Hadoop. Instead, they all will go together. So Spark right now, if you install with Yarn, I mean Hadoop 2.0, then you do not have to install anything as a server. Okay. Spark can stay like a client. Spark can stay like a client and can use Yarn for resource manager. So all the computation, actual execution will be done by Yarn for you, and Spark will just tell Yarn what to do, right? So resource management and actual execution will be done by Yarn. Just like for MapReduce, Yarn was working, now it will work in the similar fashion with Spark. Therefore, these are the few reasons why Spark is going to be adopted as part of Hadoop ecosystem. And that is the reason why I'm actually talking about Spark in a Hadoop class. All right, good question. Any other? All right, now, so next point we are going to discuss, which lots of candidates have come back and said that why don't we have a quick session on comparing NoSQLs. We had a very quick comparison of Storm and Spark, okay, where the difference between Spark and Storm, the biggest difference was Spark, the window of Spark was sub-second, while the window of a Storm, it was less than a second, while the window of Spark was few seconds. Okay. I mean, when the latency is high, so becomes your window. Okay. If the latency of a system is higher, you will have to increase your window of computation. And fault tolerance in case of Storm is really good as compared to Spark. So technology perspective, Storm has got really good strength as well as good history. But when it comes to reality, as in you will have to have Hadoop anyway, you will have to have HDFS, and you will have to have Spark anyway after a point in time because you want to do a lot of computation parallelly. You cannot keep on converting all your computation into MapReduce and cannot keep on waiting. So HDFS and Spark will go together anyway. And when you already have dedicated hardware for all of this, you would first try to utilize that uh, allocated systems instead of dedicating new systems for Storm. Okay, so those are the reasons. Similar to that discussion of Storm versus Spark, I will just go through quickly various most popular NoSQL databases. We have started calling everything NoSQL database. Though for becoming something a database, you require a lot more. Even HBase, for example, is not qualified to be called database. Okay, it is just a data store. All right, but let's just keep the discussion aside. Let's just compare what are the various database available and what are the various kinds of databases available, and how can we decide, how can we take a call which database to use when. And this is probably being, whenever you are in a technology leadership mode, you will have to take this call. So because I will go through, the main points. Okay, so that I do not confuse you further. This discussion will not be like 100% you know perfect, but this discussion will be good enough to give you an overview. All right, so the first one is Redis. Redis is an in-memory database similar to SAP HANA. It's an in-memory database, and this is basically good for doing a lot of computation on the data which changes really fast. And the data is changing really fast, and you are also doing computation really fast. Require you cannot tolerate a latency of a second. Okay, here you want the computation to be finished in couple of, at most, a milliseconds. Okay, in those cases the databases like Redis are pretty good. The only downside is that Redis is in-memory database, although whatever is in the memory is kept as a backup on the disk, but it loads the whole data into the memory. So Closure Scala is a programming language. Okay, and where did I mention that? Where did I mention this? Right. So the Storm was written in a programming language called Closure, while Spark is written in Scala. An API for this is available in Python also. I need to update this. Okay. So I can say now Python 2. Okay. All right. So these are the programming languages. Scala and Closure are the programming languages. All right, so Redis is good when you have rapidly changing data and you want immediate computation. Okay, this is not for people who are looking for batch processing, and your data might be complex. Data might be in the form of objects and in a complex graph instead of a flat relational system. Okay, this is great for doing leaderboards. What is a leaderboard? The leaderboard is showing who won how much, what is the score. Scoreboards, leaderboards. So doing those kind of computations, it is very much required that you have all of this data in memory available. Okay, say for example, when we're talking about the recommendation, so once you have done the computation of the recommendation and you are at the last stage when your data has become few GBs. Okay, from hundreds of terabytes you have converted your data into few GBs. Now you want to do further computation on these few GBs, and you have to keep on doing computation on these few GBs all the time. In those cases, it's good to have everything in Redis. Okay, if your data is small, it makes sense to have everything in Redis. All right, now the next one is MongoDB. The MongoDB is basically a document oriented database. It's pretty good database, and it provides you, similar to Hadoop, it provides you the MapReduce functionality on top of the data. Data is stored as the minimum unit of storage is a document. Okay, a document is basically the values, key value pairs, and value can be further another document. So it's a complex document. Okay, it's like having a huge XML containing values and attributes, but in a little different format. So it basically supports a JSON instead of XML. All right. So when you have to store such kind of a complex object, such as a web page, you have to cache web pages. You have to say, I mean, imagine a web page like Amazon's web page where you have lots of values, and their values can be a complex objects. In those cases, MongoDB is really good. Okay, MongoDB is really good. MongoDB is also, kind of on the architecture of Zookeeper, where you have the leader selection mechanism in place, and it has the full kind of a distributed behavior. So that's a kind of thing you have with MongoDB, and Cassandra is similar to HBase. In the cases you want to store a relational like data, but very huge size data, and you do not have HDFS available to you, or you have to choose between Cassandra and HBase, then in those cases, instead of investing too much on setting up a Hadoop cluster, Cassandra can be really good for you. All right. Cassandra has tunable consistency. Okay. So whenever you have problems statement like web analytics to count hits by hour, by browser, by IP address, and all the sort of transaction logging, in those cases this will serve pretty good. Okay. And for Internet of Things, say you have a lot of sensors, you have a lot of machinery which is accumulating data. In those cases, Cassandra will do pretty well. Cassandra has its own distributed architecture and can also run on top of HDFS. So when you do not have HDFS right away available, and you require, and also Cassandra has come up with the SQL interface. So Hector is the relational mapping. So basically it behaves like RDBMS to you, and you don't have to think too much in terms of remodeling your data. Okay, so Cassandra has done that kind of a pretty good job, where the people can continue to use it like standard SQL. All they need to do is, say, people from Java, they just need to put Hector into their project, and then they will start talking to Cassandra in terms of SQL. All right. Now, then there's something called HBase. HBase is good only in the cases when your data is really, really huge. Okay, really huge, as in billions of rows and millions of column, not even millions of rows. Okay. So so when you have far bigger data and you have a dedicated cluster already in place, then probably HBase will be good solution. And now people have started providing HBase a kind of a driver, but that's not that clean, um, you know clean ORM kind of a driver in case of HBase. But Cassandra's driver, the JDBC driver, is really, really nice comparatively. Okay. So when you have already a Hadoop cluster in place, you will like to use HBase. But if you if you want to do dedicate a separate cluster and you are okay with that, so Cassandra will win in most of the cases. Okay. So that's pretty much with respect to the NoSQL comparisons. And all right, so there are few recommendations I have to make for you guys. Okay, one is that I take you through a example. So what do you suggest about your project? Okay, I have few ideas in mind, so I'll tell those. But before that, I want to hear from you. What do you suggest for the projects? Cletus, Apurv. So session is pretty much over. Okay, we have covered almost all of the topics which we decided, and now we want to talk about the project. So Apurv and Cletus, Naveen, Sanjay, Seva, Shrikant, Sri Vasant, and Virana. So what do you suggest about your project? Okay, 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 all right. Now this is good. Okay, so let me make a recommendation to you. Okay. Yes, yes, yes. Okay, okay. So what I'll do is, so what happens is when you come up here with your own projects, the problem which I have seen is that um, you will be stuck with searching for the data, and you will have this continuous insecurity that you will forget what you have learned, right? So instead of that, what would I suggest is that let's just do a standard simple project, very simple project. Okay, uh, I'll just send you the data. Let me just download it for you. Okay, mostly we have dealt with text-based processing here, but you also mentioned about problem related to multimedia file. Yes, yes. Okay, okay, okay. So I will actually, what I suggest to all of you, you should do at least one project of your choice, but before that, you should do one project of my choice, because otherwise, you will not feel that confident in doing your own project. Okay, so what I suggest is the one project which I just did. Okay, Yeah. So this one will be non-group one. Okay. And yeah, whatever happened to my project recording. Okay. So this document is, I'll link it to the LMS also. I'll update it there. Here, so this is the sentiment files. Okay. So it's a common, fairly common project, and this is actually a good way to touch the whole thing. Okay. So it has three parts in it. One is downloading data from Twitter using Flume. Okay, that is first part. Second part is it's a sentiment analysis. And before we talk about anything, let me just describe to you what we are trying to do. Okay, so we want to compute the emotion of each tweet, whether each tweet about you is negative or positive, and then we we demonstrate that on a graph or on any tabular format, showing that over a period of time how your popularity has gone. This is called sentiment analysis. Okay. And how is a sentiment analysis generally done? First, you download the data from a source of information such as Twitter, and Twitter gives you a sample, a small sample of your total data. Okay. Now let me just help you with this. Actually, I have already downloaded into my account over here. So we have sentiment. Okay. This is the folder containing everything. All right. So basically we need to find out all the tweets from places, and you can download that using Flume. Here you can see the Flume configuration also. Okay. And for your convenience, okay, so you can see that Twitter agent here, and basically this is a new kind of a channel which they have described. Okay. You can use Flume to download the data from Twitter, and once you have done that, you can uh, you can basically start reading it. Here in this example, what we have done is we have used Hive to do the analysis. So there is a dictionary available in this. There is a dictionary available in this. Okay. So this we need to have for downloading the data. Okay. Now, so it has data. In data, there are two kinds of data. One is Twitter underscore raw data, which they have downloaded from Twitter for particular keyword, and then they have a dictionary. Dictionary contains the emotion of each word. So I'll show you that tail dictionary, for example. What's happening? Cat dictionary. Why is it saying in the single line? VI dictionary. Okay, so you can see in this file, right? You have word, word, followed by, you know, okay. So word followed by what kind of word is it? Is it negative or positive? So abandoned, for example, is negative word. While, okay, similarly, abandonment is a negative word, right? So and so on. So this contains all the words. Okay, let me convert it into DOS too. Yeah, I mean this is okay. And also, so this is there is a dictionary available in this data set. There is a time tweets available in this data set. You can see the tweets. So these are the data downloaded by the Flume. Okay. And there is a time zone map. Time zone map as in time zone to country map. So that we can say that in what country your popularity is going up or down. Okay. So the other part is the Hive in this folder. In Hive, you have all these queries available to you, and there is a JSON parser also because the Twitter data is in JSON format. And for to load that JSON data, you need to basically use this jar. Okay. In Hive, you can say add jar, and you can add any jar, and then it will hook itself. Okay. Now, once you have got hold of this data, first once you download this sentiment analysis file at some place, you'll have to upload.zip that contains the whole uh, Flume data. And once you and use zip file over here in the hue. Okay. And after you have done that, you should edit the Hive DDL SQL, the one which does most of the work, and and also copy this into your folder. Okay. And but make sure that you understand what is Hive DDL.SQL doing. I'll show you what is it doing, and you should try to understand it. What does it mean? Okay, I'll show you. So first, it creates a table called tweets underscore raw, in which it will be loading the data which is downloaded from there. Okay, here. All right. Now, next thing it will be doing is you create a dictionary. In the dictionary, this data will be loaded. And here there is something called use the row format called this, which means the actual file will not be tab separated. The actual file will be JSON format. Right. Then you have time zone, and here all these tables are external tables. So once it has created these tables, then it has started creating views on top of these tables and then did the computation. Okay. All it did was basically joined the keywords with the dictionary and then summed up the negative and positive part, and and then it has given out the results in the form of, I mean, you should go through this SQL. Okay. And also, in case you are not comfortable with the SQL, I would actually welcome somebody who can do this using Pig. Okay, I would love to do it in Pig, or I would love to do it in Spark and Python instead of doing it in SQL. Okay, here the result which it is creating is this. Okay, it gives year, month, day, and so on. And the other result it creates after this is this. Okay, create table SBI, and it will give what all field it will give. One is all the details about tweets, and then the emotions. Okay, whether positive sentiment, whether positive or negative. Okay, so look at these all files. You look at this whole document, go through it, and you can after just make this change. Remember to change this to this, okay, because there was a mistake in this. It was for the previous version. And once you have done that, you can load this data directly from Hive into your Microsoft SQL, okay, and then prepare the charts. All right. So all of you should first try to do this one before getting into your personal project. Sounds good to you? All right. So try doing it. In case you don't like Hive, you can use Pig. In case you are a little more courageous, you can try Spark also. We now you guys are lucky to have Spark now. Okay. And stay connected, as in. So I think we'll not have any session tomorrow, but let's meet. I mean, just drop me an email if you get stuck somewhere. Okay. And also, once you guys are done with the this first session, first project, you guys should let me know in case you are interested in long term project. Okay. As Apurv was suggesting to for a couple of ideas, and there are a couple of more people who want to, I mean, who want to do a little bit more digging into the topic. So in case you guys are interested, let me know. Or in case you want to run your own project and you want help in that, I can help you mentoring. Okay. So yeah, this is possibly the last session. Okay. In case you guys have something to talk about, I can keep a session tomorrow. Do you guys have specific topics in mind? All right. So we are saying that can you cover something on the installation architecture setup using Amazon AWS EC2? Okay, 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 okay. Actually, it's not a difficult thing to do, but I'll have to take a little bit of time. So let me just write an email to myself regarding this, and I'll do that for you. Okay, I'll do that for you. All right. So actually, once we have everything a good example running, I'll just invite all the past candidates to have a look at the session. Yes, yes, Sanjay. But I would recommend that you finish all the assignment. You finish this project. It's a 2 weeks project at most. Okay. So before 2 weeks, it will be great if you can submit this project. Okay. Which means next to second. I mean before the 3rd of January. Okay. So please try submitting it. It's not that big a deal. All you have to do is understand the SQL and or maybe write pig, because I would, it's pretty simple with pig. This is Hive is unnecessarily, SQL is unnecessarily complex. Yeah. So for rest of the people, you can Sanjay, you can finish it maybe by 15th of January, or maybe you guys also can finish it by maybe by the end of first week of January, because it's a holiday time. So all of you will be on holiday. Okay. So try to finish it by first week of January. Okay. At every cost. All right. So first week of January, you finish all your projects. I mean all your assignments and this project at least, and stay connected. If you want to take, if you have something in mind, you want to work upon it, I will guide you, and I'll also provide you the resources required on the server. Okay, you can continue to use it, and let me know specifically if you need it beyond 15th of January. Okay, beyond 15 beyond say 7th of January. If you want beyond 7th of January, let me know, because 7th of January I'm expecting you to finish the project. Okay, so in case you want the cloud lab access beyond 7th of January, please write to me. Also, I will keep informing you about new developments from our side. Say, for example, EC2 session. I'll drop you an email that hey, we are now up with the EC2 demo. You guys can come and join us and stay connected. And uh, if you have a particular topic you want to present to our candidates, feel free to me to connect with me, because we have got a lot of candidates as of today. Okay, and we want it to become like a educational platform, proper education platform. Okay, a knowledge sharing platform. All right, so stay connected. That's what I'm trying to say. Whether you want to do your own project, or whether there's somebody who wants to, you want to work with somebody in the team, I would actually be pretty happy with that. Okay, and in case you get stuck in your technology problems, let me know. I can possibly give some time, because I'm dedicating myself a lot onto technology part. Okay. Okay, so Sanjay, there is one guy who has actually put a lot of I'll put you with the NASA guy. I have a NASA guy in the morning session who had just finished the course. They basically provide you all the climate data, even the greenery in all across the world. Okay, so he can help you with the actual data. All right, so if you just copy paste this question to me in the email, I will reply you and connect you with that person. Okay, and then you can carry on. Okay, because after this session I'm going to sleep, and then by tomorrow I'll be busy, and tomorrow by 11 o'clock I'll be free, and then I'll connect you. Okay, by that time I might forget things. Okay, now coming to EC2. Okay, I've missed one question. Okay, Virana, could you also do me a favor? Because right now I can't open my email. Just copy this thing. Can you cover something on installation? And it'll be great. All right, that will keep me reminding all the time to devote few days to build that whole cluster. Okay, and I think I missed Naveen's question. Can you talk about applications of Hadoop stack on any real-time application which we are using on daily basis? Mhm. So in general, Hadoop is not, none of the application I have seen so far use the Hadoop in real-time applications. Most of them are into batch processing, and that is going to change very, very soon. Maybe the next version of Hive that is being released is pretty stable. But right now, as of today, the general psychology is that Hadoop and the normal stack, we use it for non-real time. Though Spark is used for real time. All right. Okay. Yes, Spark will definitely help in that domain. Okay. Most of the real-time processing happens either using those message queues, we call them message queues, or using databases like Redis, or if you have really big requirement of real time, you go for Storm. I actually built something similar to Storm for Amazon, and that was pretty good because we had to run our computing on around 40 nodes simultaneously. So we needed to build a system which could basically scale automatically and do the processing really fast. So in those cases, Storm will do your real-time processing. Then, if your requirement is little less, your the database like Redis will do a good job. Message queue will also help. So generally, in case of Amazon's website, when you look at it, the whenever you are posting a comment, okay, that whole thing is basically a real-time processing. So your comment goes and goes into the editing queues. There are a lot of checks go keeps on happening, and then uh, it goes to the right team, and then from then onwards it becomes passive. Okay, so there are actually lots of examples like Google Analytics, you see, is a real-time application. It shows you in real time that this is what is happening. But using Hadoop, I'm not sure. Using Hadoop, I'm not sure. Because even at Hadoop, Amazon, the Hadoop we were basically using for the recommendations which we show, as well as lot of crawling all the forums and downloading all the data about Amazon, doing a sentiment analysis about Amazon products. All those kind of things were done on Hadoop. But other than that, for real time, we used basically message queues and things like Apache Storm. All right. Can you throw some examples of interesting insights using Hadoop? Okay. Mm, I mean, either I am blank or is there anything interesting? Okay. I mean, most interesting insight which I found about Hadoop is that the idea of the MapReduce itself is so powerful. In the beginning, it sounds like a very simple thing, but most of the stuff is gets converted. Even in the case of Spark, it provides a query language, and even if you write in SQL and it gets converted into everything. And though at the heart of everything is just a simple sorting algorithm which they have implemented. Okay. So it's quite a interesting thing which I found. What kind of insights I can provide? Okay. So I mean Hadoop has been used in lots of cases all across. Okay. So even as I was telling you about um, Amazon, right? So the recommendations you see at the bottom, right? When you go to Amazon's website, those were done using our local system, using our normal key value data stores. Okay, and they were not very great. And after we have moved to Hadoop at Amazon, we had, I keep on telling we, but after uh, Amazon moved to Hadoop, lot of things is being done using there, and it's quite good. And even LinkedIn is using it for many things. So whenever, so far, most of the cases, whenever we are doing batch processing, that's when people were using Hadoop. But now everybody's data store for the backend is actually Hadoop. I mean the bigger data, not the relational data, but the other kinds of data. All right. So okay. Srikanth, not really, not really. We don't have that repository yet, but yeah, I can think about it. So far, people, whatever people are working, they keep their work in their home folder itself. You can have a look at that. Okay, you can have a look at that. So people generally put their work here. Just don't delete anything. So, so people keep their work here. So B Kumar is the person who has done a lot of things. Okay, he has already moved the data. Though I maintain that we have the datas of most of the people, but yeah, I haven't organized the. I mean, I haven't organized the data such that I can share it with everybody. All right, but we will do that soon. All right, so yeah, any other questions, Cletus? Apurv? So, so this is the last session for the course, and let's connect as and when you get time over the week, because my weekends are very hectic. Okay, so over the week let's connect, and then in case you get stuck, we'll help you out. But finish your sessions, finish your quizzes, finish your project. Okay, go through this particular file and try to build the sentiment analysis of uh, of a particular keyword or whatever you wish to do. All right, great, great. Have a great day ahead, and I hope these sessions were useful. And stay connected whenever you have any doubt, or in case you are starting up on a project and you are stuck with somewhere, you have doubts about things, you have to decide on some technology, we can connect. Okay. The general idea is to have a long-term relationship instead of a short-term one. Okay. So stay connected, and thank you, Sri Vasant. I too enjoyed the session, and I'll try my best to keep innovating in this domain. Yes, yes, I love that part. And sometimes I do not have time, but most of the time I can take out some time and help you guys. Right? I'll try my best to keep my time for technology. Great, great. Thank you very much. You have a great holidays ahead, and stay connected. If you have any doubts, if others want to share something, and also be active on the forum. Try to answer the questions on the forum. I'm hoping that you will be able to answer the questions on the forum. Okay? Okay. All right. And also, in case you guys are looking for a job, we will be sending you a forum. Anjana will be sending you a form, and you can fill that up. I mean, our enterprise partners, they keep sending us email about openings, and we'll connect you to them. All right. And this is only true for those people who who are not from enterprises. There are few people from in this session who are from enterprises. We may not be able to forward your CV to any other organization. All right. I mean, for those whose payment was done by their companies, okay, for them we cannot really forward the CV, but for others we'll be able to forward your CV. All right. So we'll connect you to a couple of people who are in this industry looking for this thing. We do not seek any kind of revenue from either side. It is just like a campus placement thing for us. All right. Thank you very much. Stay connected. Bye. Bye, Srikant. Okay. Bye, Siva. Bye, Naveen. Hey, Naveen. Actually, we were in process of sending your CV to some people. Okay. Just connect with me after this session. Okay. And thank you, Cletus. I hope you enjoyed the sessions. If you have any doubts, just drop me an email or schedule maybe 15-20 minutes time for this further discussions. All right. All right. Bye, Naveen. Bye, Apurv. Have a great day ahead. All right. Bye bye. I'll log off now.